Welcome to Quantum Kinetics Corporation. I'm your host, the CEO, and today we're going to be talking about the electron and how the electron is composed of multiple faceted understandings of the universe and how we can use those understandings to induce cold nuclear fusion on demand. So if you're interested, go ahead and stay tuned all the way to the end of the video. The basic understanding of the electron as we know it now is that the electron is a point-like charged particle radiating out electrostatic fields and also a magnetic field, which means it has mass. And this mass particle can emit radiation in the form of electromagnetic radiation if you agitate it. If you want to learn more about that, go ahead and check out our very first video. But you have to understand that the electron is actually a multifaceted particle that is also here and there at the exact same time. And we know this because of the Schrodinger's equation and also, most importantly, the Heisenberg uncertainty principle, which basically just states that if we measure the electron's location, we'll never know its energy. And if we measure its energy, we'll never know its location. So you see, the electron is kind of an elusive particle that's here and there at the exact same time. And we may be able to use that to induce nuclear fusion on demand. So now that we know that the electron acts like a wave, but it also acts like a particle, is there a mathematical computation that allows us to understand the behavior of the electron? And there is. It's called the Bessel Function. It was derived by a guy named Frederick Bessel back in 1824. And he was working closely with Kepler, and he was an astronomer. And they were trying to understand how the universe would operate and move around and function in space. So we may be able to use this when we determine how the electron moves. The Bessel function calculates many different behaviors in the universe, including electromagnetic radiation, heat conduction, Schrodinger's equation, quantum Feynman propagation, DNA, and even the electron's behavior. And so we can use the Bessel function for a variety of understandings of the universe, and most specifically the electron. And so we're going to dive a little bit deeper into how this equation can be used to understand how light interacts with matter and how matter interacts with light. The Bessel function is a second-order differential equation, which means that there's a stable state and an unstable state, much like the electron. And as you can see here, that the first order is stable where the wave crests are equally distributed, and this would represent the point-like charged particle that the electron actually is as mass. If you look at the second order, you'll look closely, you can see that there's a phase shift from the center line, which would imply that there's a pressure being pushed out into free space. And this is what happens when you have the agitation of the electron. It will emit electromagnetic radiation into one side or the other side of the universe. And this is also supported by the equation E equals mc squared, which basically just states that the mass is the same as the energy times the square of light. When you agitate matter, it will emit electromagnetic radiation into free space. However, this is only half the equation. So in order to understand where electromagnetic radiation actually comes from, we have to first understand that the electron also is associated with a positron, which is a basically negative mass particle. And this negative mass particle has negative inertia, and it also has negative mass, and it also is going backwards in time. The electron is going forward in time, and the positron is going backwards in time. And when they interact with each other in a phase-shifted manner, they will emit a positive light and also a negative light. This is important to understand this because there's a thing called zero-point energy. And what zero-point energy means is that essentially that everything in the universe has an infinite energy density, which is something that Paul Dirac talked about. It's called the Dirac sea. So the reason why we have never figured out cold nuclear fusion until now is because no one has been equating in their mathematics and their devices this thing called antimatter, which is a real entity. It's going backwards in time and has negative inertia. And actually, I would say that the antimatter is more powerful than the electron itself because it actually has slightly bit more energy into it as it's spinning around. And we figured this out using cloud chambers. And so in order to trigger safe nuclear fusion on demand, you have to learn to tickle the antimatter in a very specific way with a circuit design. So in order to trigger safe nuclear fusion on demand, you have to first understand that the equation E equals mc squared is only half right. The real equation is E equals plus or minus mass times the square of light, which means that there's an electron up here and a positron down here in a Bessel function. And if you understand that, then you can start doing these weird things where you do phase shifting, where you actually take light and then turn it into matter. And that's what we do here at Quantum Kinetics, using the phase shift principles of electromagnetic radiation into matter, and then we can create condensed matter, we can create carbon, we can create nitrogen and oxygen at low power. Another interesting point to make out is that when you look at a Bessel function, you also have this thing called cosine, sine, and tangent. And normally, when it's stable, the electron, it's in a cosine phase relationship regarding the antimatter. But as you see here, when the electromagnetic radiation is being pushed out, it's in a sine wave configuration. But you can also have a tangent configuration, which means that the light is actually being pushed back into the electron in stability. And when we do this with our circuits, we can actually cause an electron capture event, which causes a hydrogen atom to turn into helium, lithium, barium, beryllium, and carbon, and we can go all the way up the chain just by determining how much electron voltage we do to this negative ionization event using the Quantum Kinetic Well or the arc reactor fusion on demand. I hope you enjoyed this episode regarding the electron and how it actually functions in the universe. If you really like this content, go ahead and make sure you like, share, and subscribe. It really helps out the algorithm, gets us moving forward so we can get this technology to you as fast as possible. And always remember, fusion is love and love is fusion. You don't have to force it. It just happens. We look forward to seeing you on the next episode. Have a great day.